So I just wanted to meditate a little more about these angles. So I've cleared my screen and look what happens when I do this. I have a side length of 300 and my angle is something slightly weird, in this case 115 degrees. I just thought it was quite pretty. So you can see this shape is actually quite complex, but it actually turns out, as you can see, that we need quite a few revolutions to actually make it to a point in the life of the turtle where the remainders is 0. So what I did was, let me just realign it a little. Yeah, 160, something like that. Yeah. So what I did is I've made a variable I call segments. It's just a word. And you can see inside, it's like a counter. Inside my POLYSTOP, I said, when you start, set the segments to 0. And when you go into the repeat loop, then change the value. There's a block called change variable by a given increment as a given value, and in this case 1 is super fine. So actually what this tells me is that I have 72 segments before I'm actually back to the 0, before this shape closes up. So if I was to do a manual repeat loop, I would have to put in 72 to make this shape happen. And just for fun, so what we can say now is how many segments. If I know my segments, so if I said I have so many segments and I'm using, in this case, an angle of 115, how many degrees have this mouse or this turtle traveled to be able to get home again? So you can actually see that if I just take a plus multiply here and click it, you can see that our segments are 72, and we've done that with an angle 115. So we've done it so many times. So if I divide this by 360, it should actually give us the number. How many times around the circle have you traveled for this shape to happen? And you can see it has been 23 times around the circle for this to actually turn into a full circle. So, I mean, it's much simpler if you take an angle like 72, because we know, well, now it's too big, but we know that it's sort of, there is no remainder. Sorry. There is no remainder when we have, and we only need 5 spins in the carousel. And you can see if we take this calculation, you can see it only takes 1 trip around the. What if I said 71, just to be very annoying? Let's see what happened. And you can see it would have to travel a lot, many degrees to actually make this happen, because 71 is not one of our super. So you can actually see, for now, just for fun, we would need 71 revolutions to actually make this happen. So how many angles are this? I just want to know how many degrees. So it would have to travel 25,560 degrees to actually be able to get back to the point where there is no remainder. So you can see it actually is quite nice sometimes to have a little helper that can actually help you. I know, what about 66? Let's see how that shape looks. Well, it's not very distinct. I get them more distinct if I make the value higher. And you can see you can get some more. What if I did 160, say? They become quite pointy, yes. So, and you can see, let's try this calculation. So we have 9 segments. So this should be a 9-pointed star. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so it is. And we've traveled 1440 degrees. This is a very classical, where we need 4. So what would happen if I set 80? You can see it still makes sense, but that is just half the way. So it would make it in 2 convolutions or revolutions, and so on and so forth. So if I say 160, we would need, yeah. And sometimes it's fun just to play around. So if I take the double again and make it 320, how would that shape look? I know it should make sense. And then you can see, we have a totally different approach, because this is just a 9-fold. We're back to a rather simple one. So sometimes it's actually fun to just play around with these angles and play around with these blocks and see what happens. I rather like this one. It's kind of a star. Yep. It's just to actually show you that you can actually do some very nice calculations actually quite easily to become more. So this would mean that I would have to go, well, it's actually the same we're saying, 4 times around as a 4 times 360, because it has traveled 1440 degrees. Yeah, it's actually just to show you that you need to sort of poke around and get to know stuff. And but this stopping ability is actually really nice, and we'll build on this in the future.